Hi everyone, welcome to this video going over activity 14, altitudes, medians, and angle bisectors of triangles. In this video, we are going to talk about 3 different segments that we can draw on a triangle and what a point of concurrency is. So the first segment we're going to talk about is an altitude. An altitude of a triangle is a segment from a vertex of a triangle. So when I say vertex, I'm talking about the 3 corners. All of these are vertices, which is the plural of vertex. So a segment from a vertex perpendicular to the opposite side. So I need to draw a line from a vertex such that when it reaches the other side, it makes a 90-degree angle. Now let's think about how many altitudes I can draw on a triangle. Well, since a triangle has 3 vertices, I can draw an altitude 3 times. I can go from this left vertex to the other side, and it can be perpendicular. And I can go from the right vertex, perpendicular to the other side. If you have a protractor with you, I would highly recommend using your protractor and locating that 90 degrees to help you make a 90-degree angle. And a point of concurrency is a point where 3 or more lines intersect. So notice how I drew 3 altitudes of this triangle, and they all intersected at the same point. That's called a point of concurrency. So let's practice drawing our 3 altitudes for the triangle down below. If you have a protractor, please line up the black line at the bottom of your protractor with your first side of your triangle. So let's do this bottom side. And once you have your protractor lined up, slide your protractor until you see that your vertex is lined up with the 90 degrees. And then make a point up at 90 and a point through the hole in your protractor and connect those 2 points. And you should get a line that goes straight down from your vertex and makes a 90-degree angle with that opposite side. And you can do this 3 times, once for each vertex. So after you draw that first altitude, then line up your protractor with another side. For example, the side on the left. And you want to make sure that this vertex G is lined up with the 90 degrees, and then draw your altitude. And then one more on the other side. Please try to make your lines as straight as possible. I know my lines aren't that straight, but I'm not using a protractor. Please make sure that you line up your protractor, draw a point up at 90, and draw a point through the hole at the bottom of your protractor and connect the points. And you'll notice that all of my lines intersect at the point 12, 12. I'm counting by 2, so that is the point 12, 12. And the point of concurrency for altitudes has a special name. The point of concurrency of the altitudes of a triangle is called the orthocenter. So if I ask you to find the orthocenter, you need to draw the 3 altitudes of a triangle and find the point where all 3 intersect. And for this triangle, the orthocenter is the point 12, 12, because that is the point where all 3 altitudes intersected. Let's move on to talk about our next segment. Our next segment is a median of a triangle. A median is a segment from a vertex to the midpoint of the other side. So let's say that this was side AB and the midpoint was point M. A median goes from the vertex to the midpoint of the opposite side. It is not necessarily perpendicular. All it needs to happen is that it goes from the vertex to the midpoint on the opposite side. And once again, each triangle has 3 medians because there are 3 sides to a triangle and 3 vertices. So let's draw the medians for this triangle down below. Since the median needs to go through the midpoint, I'm going to use my midpoint formula. Remember, the midpoint formula is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So let's find the midpoint of each side first. So let's find the midpoint of side AG. So I'm going to add my x's. So the x of A is 0, plus the x of G is 36, and divide by 2. And then we're going to add the y's. The y of A is 0, and the y of G is 0, and we're going to divide by 2. 0 plus 36 is 36, and 0 plus 0 is 0. 36 divided by 2 is 18, and 0 divided by 2 is 0. So the midpoint of AG is 18, 0, which is right here. So to draw the median for that side, I need to draw a segment from the opposite vertex, which is C, to that midpoint. That is my first median. Now let's find the midpoint of side CG. So the x of C is 12, plus the x of G is 36, and divide by 2. And now we're going to add the y's. The y of C is 24, plus the y of G is 0. We're going to divide by 2. 12 plus 36 is 48. And 24 plus 0 is 24. 48 divided by 2 is 24. And 24 divided by 2 is 12. So the midpoint of CG is the point 24, 12 right here. And so to draw the median of that side, I need to draw a segment from the opposite vertex, which is A, to that midpoint. And lastly, let's find the midpoint of side AC. So to find the midpoint of side AC, I need to add the x's. The x of A is 0, and the x of C is 12. And add the y's. The y of A is 0, and the y of C is 24. 0 plus 12 is 12, and 0 plus 24 is 24. 12 divided by 2 is 6, and 24 divided by 2 is 12. So the midpoint of that side is 6, 12 right here. And so the median of that side goes through the midpoint and connects it to the vertex. And this point in the middle is my point of concurrency. And the point of concurrency of the medians of a triangle is called the centroid. So just like with the altitudes, the medians have a special name for their point of concurrency as well, and it's called the centroid. And the coordinates of that centroid are 16, 8. Remember, once again, I'm counting by 2's. So this x value right here is 16, and this y value is 8. Now, there's a special theorem about the centroid of a triangle, and that theorem is called the centroid measure theorem. And it says the distance from a vertex to the centroid is twice the distance from the centroid to the midpoint. So, for example, if x is my centroid, and notice how all my m's are my midpoints, the distance from the vertex to the centroid is double the distance from the centroid to the midpoint. So if the distance from B to the centroid was 10 units, I have to divide that by 2 to find the distance from the centroid to the midpoint. So that means that the distance from the centroid to M1 would be 5. Let's say the distance from midpoint 2 to the centroid was 8. To find the distance from the centroid to the vertex, I would have to double that. So that distance would be 16. And lastly, if the distance from C to the centroid was 30, that's double the distance from the midpoint to the centroid. So dividing that by 2, the distance from midpoint 3 to my centroid would be 15. So just know from any vertex to the centroid is twice the distance from the centroid to the midpoint. And lastly, our last segment we are going to talk about in this video is an angle bisector. We know what an angle bisector is. It divides an angle into two equal parts. So if I was to draw an angle bisector for this angle on the left, I would draw a line that splits that angle in half and then reaches the other side. And I would do that for every single angle, splitting it directly in half until it reaches the other side. And every triangle has 3 angles, so every triangle has 3 angle bisectors. And in order to do this perfectly, what I would do is I would use your protractor to measure the angle and then divide that angle in half. So for example, if an angle measures 60 degrees, mark where the 30-degree angle would be and draw the angle bisector to split that angle in half. Since I don't have a protractor right now, I'm just going to eyeball it. So splitting this angle in half, splitting this angle in half, and splitting this angle in half. And just like with altitudes and medians, the point of concurrency of angle bisectors has a special name. It's called the incenter. And the incenter, most often than not, will not land at a perfect point. This one should have landed about 14.446 and 8.928. I think I'm a little off with my eyeballing, but hopefully if you used your protractor and actually split the angle in half, you would have gotten a little closer to what it was supposed to be. And the last piece of information I want to tell you is that the incenter is equidistant to the 3 sides. So the distance from the side to the incenter for every single side is the same. So all of these segments have the same length. They are all congruent. They are all equidistant from the incenter. And those are our 3 segments of a triangle. We have the altitude, the median, and the angle bisector. I would pay most attention to the median because that one we can make the most exact by using our midpoint formula. And so that is going to be the one that I quiz and test you the most. Please let me know if you have any questions, and I will see you in class.